Hello, this is a demonstration for an open source project called ztachip. So ztachip allows you to run vision and AI application on FPGA. So here is a development kit from Diligent. So here's the FPGA chip. So the FPGA chip is used for if you need some like customized hardware interface in your design. So FPGA is usually good for that because not all design can run on off-the-shelf hardware. Like for example, if you have like a special peripheral that you need some special signal interface, so FPGA is a way to do it. So this project show you how you can also put a RISC-V processor plus some acceleration to achieve good performance vision AI applications. Okay, so here I'm going to show you how it works. So it running using Micropython, so it's like very easy to use. So I would just cut and paste some example from the repo. For example, here the edge detection example. So you just put it in the serial port of the Micropython. The Micropython. So you paste the code here. So Micropython, you can paste the code directly on serial port by hitting Control E, paste the code, and then hit Control D and execute. So you can see now that you see edge detection is working. So at the display, it shows 30 milliseconds. That means it go faster than what the webcam can provide. So this is all under Micropython, right? So it shows that even with Micropython, you can still have very good performance. So you hit any key here to stop. Then you can try other example here. So monochrome display. So here it will convert your color display to a monochrome display. Control E, paste the code. So you see how easy it is. Like you don't need to recompile the code, anything, right? Just cut and paste. Just cut and paste the code and on the screen you see it show 30 millisecond. So that means that it's faster than what the webcam can provide. Okay, hit any key to stop, and let's try other example. So let's try some example involving AI, right? So AI, this object detection is pretty popular. This is running more TensorFlow Lite model called SSD MobiNet. So again, you paste the code directly on the serial port. And you hit Control D, execute. So here it's running at 200 millisecond. You can see on the display it shows 200 millisecond. So this is a little faster than Raspberry Pi 4 actually. So you can see that here it's detect the cup, right? Okay. And some image detection. So another popular AI model is the image classification. So this is SD MobiNet. Oh no, actually MobiNet from TensorFlow Lite. So you hit Control E, enter. Control D. Yeah, so you see it's pretty fast, right? So let's take the cup here. Coffee mug, 62%. Okay. So it can get pretty complicated if you need it to be. For example, you can do multiple tasks simultaneously. So this is a more advanced example. So it was like a pretty big graph. So all of these examples here, you're going to find it on GitHub, the repo for ztachip. Okay, Control D, execute. So here it's going to actually have two graphs, right? The slow graph, the non-vision AI, non-AI task will be on one graph. So it's like you got edge detection, you got point of interest detection, and you got optical flow. So you can see the motion here, detect the motion on the bottom right corner. And there's a second graph that doing AI. So it's on the top left to see it's doing also AI detection. Yeah, so it's you can do quite a lot with this. Multi-graph, multi-programmings. Yeah, so that's it. So I hope you find it useful. Thank you.